So today we will be talking about direct variation. And direct variation is a linear function. Linear. So linear means it is a straight line. A function means if I put in one value for, say, x, I will get out a y, and one and only y. That's what a function is. Okay? And it can be written in the form y equals kx, where k is a non-zero constant, so it cannot equal 0, and it is called the constant of variation. Okay, the constant of variation. So we are going to, for now, we are going to solve y equals kx for k. Y equals kx. So we are going to divide both sides by x. Okay, so that disappears from the right. We are left with y over x equals k. And k, remember, is our constant of variation. Okay, the value of k is the ratio of y to x. And that means this ratio, if we're given a set of data, that the ratio is the same for all of the ordered pairs. In other words, y relates to x the same way. And the graph of a direct variation is always linear. In other words, it has no exponents on any of the variables. And it must always contain the point 0, 0. Okay, that's just one of the rules. And as you know, that the point 0, 0, we could plug that in, y equals kx. If we put 0 in for both x and y, we get 0 equals 0. And we know that's always true. That's why 0, 0 is always part of direct variation. So you can determine if data is a direct variation. You can plot the points on a graph and determine whether that makes a line. You could do that. It works most of the time. Sometimes the points get a little weird and you can't tell if you just plotted them sloppily or it really is not direct variation. What I would do is compare the ratios of your data. So in other words, we're going to take this set of data. I just made up some points. Here's my x on the top and how it relates to the y. So we're going to compare ratios, and ratio is, essentially two fractions set equal to each other, two proportions. So I am going to take this first set of data. I'm going to put my y over my x, and then I'm going to do the same thing, so say for this last one. And we are trying to figure out if these two proportions are equal. In fact, if it does form a ratio. And if it does, then we could say it has direct variation. So you could do it this one of two ways. You could use your calculator and create, try to figure out the decimals here. Or you could cross multiply. So I am going to try that method here. So 39 times 11, and I already figured that one out for us, and that is 429. And then I have 7 times 45, and that equals 315. And we know that when we have a ratio, the cross products must be equal. So we found that they're not equal, therefore this is not direct variation. Okay, so let's do another one. We have a set of data x and y. So we are going to set up some proportions. 4.5 over 6. And then we're going to do 6 over 8 and 9 over 12 and 15 over 20 and 21 over 28. Okay? So we are trying to figure out if this is a direct variation. So in other words, we could pick any two of these, put them equal to each other, and then do the cross products. Or we could figure them out as far as a decimal. Now I went ahead and I looked at the decimal method to do it first. And I found out that 4.5 over 6 is 0.75. 6 over 8 is 0.75. 9 over 12 is 0.75. 15 over 20 is 0.75. 21 over 28 is 0.75. So since all of these are equal, all of these proportions are equal, therefore, yes, this is direct variation. Now, what we can do is we can find the equation of direct variation. In other words, we can find y equals kx if we are told that something does directly, if it varies directly. So if y varies directly with x, in other words, we have direct variation, we're going to say y is 48 when x is 3. So what we're first going to do is substitute these numbers in for x and y. So y is 48 when x is 3. So I have k times 3. Now we're going to divide both sides by 3. So I get 48 divided by 3, which is 16. 16 equals k. Now what we're going to do is we are going to substitute this 16 back into the original equation. So y equals 16x. That is our equation of direct variation. Let's do one more. Y is 15 when x is 10. So we are going to substitute for the y and the x. 15 equals k times 10. We are going to divide each side by 10. So 15 over 10, we can simplify that, dividing each numerator and the denominator by 5. So we get 3 over 2 equals k. We are now going to substitute it back in for our k. Y equals 3/2 x. And there is our equation of direct variation.